First thing up, we'll go to our warm-ups. Go to your warm-up packet. Should be sitting in there. We are at number 15, and due to time constraints, we're just going to do these together. Everything we do today, you'll have a calculator, so take your calculator out. I am not going to be punching anything on my computer calculator on purpose. I want you guys to have yours out, know exactly what buttons to push, and I will give you plenty of time to use your calculator. So in your warm-ups, we'll do 15. We can't do 16 because the copying didn't come out very well. So 15 is an oldie but a goodie, a particle motion question. We'll be reviewing particle motion in depth next week. It's a full day. But let's see if you remember enough to answer this one. You are given the velocity of a particle. I like to put it in a box, what I'm given, and then it asks me the total distance. I usually like to circle that. And I like to go like this. And again, you have your own test-taking strategies, but I make so many keys, and I usually do that. I box in what they give me, and I circle what I need to find, and I figure out how I get there before I even read the question. How do we go from velocity, which is in meters per second, back to meters? What calculus operation does that? Integration. So that's the first thing you do is decide whether you've got a limit, a derivative, or an integral, because that's all calculus is those three pillars. This is an integration question. My limits are given. They're time constraints. I need to integrate my velocity to head back to position. If you go enter that on your calculator, you'll get an answer that's sitting there and it's wrong. So can you tell me what's wrong with it? Why isn't that going to give me the right answer? What'd you say, hon? I do. I need absolute value. For total distance traveled, I want when I'm going backwards to count on my odometer. What would I have found without the absolute value? This would have said something else. Do you remember what? Displacement. Yeah, so when you go enter this on your calculator, Math 9, 0 to 2, do you remember where the command is for absolute value? It's been a while. Do you remember what that's under? Math num. Yeah, so if you go enter that in full, and I am going to give you a little time to do it just to tackle the icky integrand there, 3e to the negative x over 2. But this is entirely calculator active, so do nothing by hand. No product rule, no chain rule, no u sub. And I believe if you enter it correctly, you'll get D. Can you confirm that? All right, so D is the correct one. Next up, 16 we can't do. It copied weird. Number 17 is nice and easy, so I'll do that one quickly. Number 17, just a graphical interpretation of continuity and limits. So this one says that my limit as I approach B has to exist. So I know that wherever my answer is, the limit exists there, but it also says that I'm not continuous at B. So this is what I'm looking for graphically. Somewhere where I lift my pencil, because it says not continuous, but there's a limit. And there's only 3 discontinuities up there, the asymptote and the 2 jumps. Which one is it? The one at what? 0. Yeah, the one at, excellent. The one at 0 has a limit. What is its limit? 2. Exactly. But it's discontinuous. So that one I think you would get nice and easily. Number 18. Sorry, it's not scrolling very well. Number 18 says f is a function such that the second derivative is negative. What does that mean about f? It means it's concave down, but that doesn't help me because I can't see the graph. So this is what I need. I need to go from f double prime back to a question about f prime, right? So I really need to think about what must f prime be doing? When f double prime is negative, what's f prime doing? Decreasing. Exactly. F prime is decreasing. That's what I know. So I need to make sure that whatever I choose something where f prime is decreasing. I need to go figure out what f prime is. I can't really, but I can get a good idea of it because when I have f and I'm looking at f primes, I'm looking at slopes, right? Wouldn't you agree? So if I go find the slopes up here, if I subtract my y's, 0.18, over subtract the x's, 0.1, When I divide those, I'm dividing, you could do that on your calculator because it's calculator active, but instead of dividing by 0.1, I'll multiply by 10, and I get a 1.8 right there to the right of it, right? And over here, same thing, I'm going to go to the left of it and analyze the slopes over there, and the slope of the secant line over here would be 0.2, right? And then that's 0.1. When I divide them, again, I'm just doing change in y over change in x, change in y over change in x. I get a 1.8 to the right and a 2.0 to the left. Again, just y2 minus y. Are you okay with what I'm doing there? It got kind of sloppy. So which one has those as the constraints? Who's my answer? D. Yep. Last up, calculator active again. Number 19. Two particles start at the origin and move along the x-axis for a time period of 10. It says the positions are given by, so I like to put those in a box. And it says for how many values do they have the same velocity. So again, what calc operation takes you from position to velocity? Is that a limit, a derivative, or an integral? That's a derivative. So I want to know when the velocities are the same, so I'm going to set this equal to v. There's two ways to do this, by the way. I'll do it the way most people would attack it. Take the derivative of the first particle, I'll call it v1. Take the derivative of the second particle, e to the u, du. I want to know where they're the same, correct? So I want to know where cosine of t is equal to negative 2 e to the negative 2t. I have a calculator. That is not readily apparent to me how many times that happens. But do you remember what I said the best way to solve things are when you have a calculator? What did I say to do? Get it equal to 0. Because sometimes if you, I know when first year I taught this, I used to tell them to put that in y1, that in y2, and look for where they cross, right? The problem was if they crossed out of the viewing window, like too high or too low, the kids couldn't see that. And so they would see it cross twice and not realize it crossed somewhere where they couldn't see it. So what's easier is to get it equal to 0 and just go like this and put this in y1. Then all you have to do is look at how many times it slices through the x-axis. And what that means is you don't have to worry about your y on your window. Just set your window to go from 0 to 10 by 1s. And put this in y1, hit graph, and count up how many times that happens. That's easier than graphing them separately and looking for intersections. Physics people, make sure you go put your calculator in what? Radian mode, because you probably are in degrees from physics. So if you go enter that in y1, set your window to go from 0 to 10, and hit graph, and count up how many times. I'm looking at Marlis's. Hers is hitting 3 times. Can someone back that? Yours is 2, Noah? All right, perfect. So there's 3. These are very typical multiple choice questions. Are you going to have the same ones? No. But they'll be the same topics. All right, so next up, we're going to start Frappy number 2. Frappy number 2 goes better for most people. Here's why. It's much more common sense. In Frappy number 1, things were arbitrary. You didn't know what F was. You didn't know what G was. The graph was weird. It didn't stand for anything in real life. It was pure calculus in its purest form, right? This stuff has a lot more common sense with it. So if you can get your brain wrapped around the situation, these tend to improve dramatically with review. I like to call them rate in, rate out. What will happen is, our book calls them accumulation problems, but it makes more sense to discuss them as rates. You'll be given something where stuff's coming in and stuff's going out. I can't tell you what the stuff will be, but I can tell you what it's been in the past. They've had water going into a drain pipe and there being a leak in it. They've had a wastewater treatment facility with water going in, being treated and leaving. They've had a compost pile in like 2014 where stuff was being dumped in a pile right in, but it was decomposing. Are you good with that? Sometimes they only give you a rate in, like the one where you're going to do for your homework is people waiting in line at a rock concert to get in. And it's the rate that they're letting them in the door. They're not leaving though. They're sitting down to watch the concert. So you'll either be given a rate in and a rate out, or just one. But it's all the same stuff. let's go take, it's kind of like, I'm going to give you just a generic situation just so you can wrap your brain around it. It's like the chicken nuggets in the lunch line. Before you guys get to lunch, what do the lunch ladies do? You're serving nuggets today. They put nuggets in the serving bin, right? There's some there before the bell even rings. And with these problems, that's what usually happens. There's usually something already there before, like there's oil in the barrel, or there's people already in line before the ride breaks down, or something like that. There's usually some start amount. And then what happens is the bell rings for first lunch, and you guys go there. And what do? You start having a rate out. You take nuggets out. They give you a 6 on each tray, right? Or 7 or 8, whatever. I don't know. I don't eat them. They're gross. Um, and then what are the lunch ladies also doing? They're making more. So there's a rate in, right? And the types of questions they ask you is they'll ask you when there's a maximum amount of nuggets in the bin. It won't be nuggets, but same type of thing. Or they'll ask you how much were in the bin at any given time, or when were there the least amount. So usually what you're given is a rate of change. Generically, I'm going to call that R prime, but it need not have to be a prime. They might call, like velocity is a rate of change, and you don't see the little derivative that's there, right? But it's feet per second. So you're usually given some rate. All right, and there's usually a time period. I'm going to put that in a block too. On a work day, that would be from like 0 to 8 hours, or from like 9 a.m. to 5 p.m. But there's usually some time window that you're looking at. These are very applicable in real life, actually. We know that the fundamental theorem of calculus of it says this, but I'm going to explain it outside the calculus in just a second. The antiderivative of r prime is just r. Do you agree? Because the derivative of this is that. Really what this is saying though is to go from the rate, when you integrate, these undoes the derivative kind of and you're right back to a quantity. Let's go put r prime as, let's say it's tons of garbage per hour being dumped off at the landfill in Elk River, right? And dt is a change in hours. So this is the rate that the trucks are bringing it in over hours. When these cancel, what does that leave me with? Tons, a quantity. That's what the big R stands for, is how much is there. All right? And to get how much is there, I take how much is there at time 2, how much was there at the start, and I'd subtract them. Doesn't that make sense? Right? So, and you guys are super listening. I can see it in your eyes. I love it. All right. However, what you're usually looking for is how much there is at the end of a time period, at the end of a workday. How much is left? At the end of the lunch hour 4, how many nuggets are in the bin? Do you think you want to minimize that or maximize that? Oh, definitely minimize that, right? You'd like there to be none. However, that's almost impossible to control because the rate in is a little, it's not constant. Anyway, to get the amount there at the end, and it says, what does this really mean? I'm going to take it out of the calculus. I'm going to have you go like this. Who cares about r and t and the integrals? This just says the amount at the end. Amount at end is going to be equal to, what do you think I'm going to write for this one in words? Amount at the beginning. Yeah, amount at beginning. I'm not going to say at time 0 because sometimes they have you analyze it from like 1 to 3 hours, and that would be the amount at time 1 then. But the amount at the beginning plus, what do you think this stands for? That's why our book calls it the accumulation function, because this tells you how much accumulates over that time period. So I'm going to put the amount you accumulate on that time period. All right, so that's really what it means. We're going to do 2 of them. We're going to do one where there's just one rate given and one where there's 2. We're going to save the geometry one till everybody's here because it's the trickier one. So the first one in your packet with the hamburgers, that's going to sit. We will do it, but I'm going to wait till everybody's here. We're going to go to the roller coaster. Here's what makes these usually go better for people than the last set. If you can get a good picture and wrap your brain around what's going on, common sense can help. It doesn't become all math. So you've got a roller coaster, all right? Here at Valley Fair, roller coaster broke down and a line forms. Now I'm making a really crappy picture, but it's good enough. Go like that. Just draw. I would always, for a rate in, rate out, I would draw yourself a really bad picture. It says at the time that the ride opens, there's 400 people waiting in the line. I'd put a 400 right here. There's 400 standing there. Over the next 30 minutes, I like to just put a continuum down here so I know I'm looking at 0 to 30. If it was a work day, there's one where you're going to have a woman, her name's Janet, and it's snowing, and it's been snowing all night at a certain rate, and she gets up at 6 in the morning and she starts to shovel. So you got the rate in, the snowing, right? You've got some already there because it started snowing at midnight. She doesn't get up till 6. So there's an accumulation already there. Then she starts to shovel, and there's a rate in and a rate out. All right? So this is a 30-minute continuum. And it says that the rate of change, that's important because they're calling it W, and that bothers people because they're used to having a rate of change have the little derivative there. They're taking care of the word derivative by putting that there. So you need to know the rate of change is W of T. I'm going to write W of T, and that's in people per minute. Labels are really important with these. So here's what they're giving me. They're giving me how many people are in line. There's a lot because the ride broke down, right? They're fixing it. 30 minutes. They have it open. W of T is giving you the rate of change in people in the line. So let me ask you a couple questions. If WT is negative in this scenario, what does that mean? W of T negative means what's happening at that ride. The line is getting shorter. Okay, just have a concept of that. W of T being positive means what's happening. The line is getting longer, right? And W of T equaling 0 means as one person's walking up to the line, what's happening? One person's getting on the ride. So just to get your brain wrapped around it. First question, okay, it says what percentage, how do we get a percent? We do something over a total, right? So that's an important word. Over a 30-minute time period, so it's a percent of 30. Was the line getting shorter? The line is getting shorter, right? When W of T is what? Negative. So, and I have a calculator. So the first thing you're going to do now is go put this in Y1. So go to your calculator and enter it with the X's. And before you hit graph, we've got to keep that window going. Down here is our time in hours, or sorry, in minutes. And we're going to graph W of T, which is going to be people per minute. And we've got to have our minutes go from 0 to 30. So after you enter that, go hit your window. Have X scale go from 0 to 30. I always divide it by 10. So I go 0 to 30 by 3. Are you all right with that? Next step. The Y one I'm not as concerned about because I really am just looking for it goes positive to negative, but I can tell that like at 0, it's going to be pretty big. So maybe, and do I need to know where it's negative? Yes or no? Like, do I need the negative stuff or can I start at 0 for the Y-axis? I need the negative stuff, right? It's a rate of change, and that's exactly what I need here, is when it went negative. So let's try on the Y, maybe going from negative 50 to 50 by, I don't know, by tens or something. See if that's a good enough window. If not, it doesn't have to be perfect, but you need to see where it goes negative. Did you use that window, Marlis? Perfect. I can totally see it on hers. I'm going to steal it. So hers looks like this. And again, I don't really care right now. I just want a general graph. There we go. Question says, what percentage of the time over the 30-minute period was the line getting shorter? Right? The line is getting shorter in this negative region right here. So what do I need to calculate? The intercepts, okay? So let's go do that. If the left side of the room, if you guys could get the first one, it's 4.9 something, but I don't remember the rest of it. The right side of the room, if you could get this one, it's 22 point something, but I don't remember the rest of it. We need those intercepts. 159, okay? And 4.924. Thank you. That's the time period. So for me to figure out what percentage of the day, of the time period it was, you could just subtract them. And then divide. That'll be the time period out of a 30-day window. And I'll tell you what percent that was from last hour's. 57.45% of the time the line was getting shorter. All right. Next. during that period of time that the line was getting shorter. So I'm still looking at this squiggly stuff on my graph. How many fewer people were there? How do I go from people per minute to just people? This is an integration problem. This is actually area under a curve. Remember, when you do integration, you're adding up all these little rectangles, and this is dt in minutes, and this is w of t, people per minute, and when you multiply them, you get people, right? And it's going to be negative. Why will it be negative? It will be negative. Why? The line's getting shorter. W of t is negative. It's below the x-axis. There's a lot of reasons you could explain that, but know to integrate and know that you need to do the time period when the line was getting shorter, right? And you're going to integrate that curve, and that'll tell you how many people. The curve itself is the rate. The area under the curve is the quantity. Okay? And if you do that on your calculator correctly, I want to say it was negative 309. Can one of you back that? Who's fast? You got it, Joel? Thank you. So you get negative 309. Now you have to be careful how you answer the question, because sometimes College Board will give a point and it'll say, student answers question correctly in the context of the problem. So when it says how many fewer people were in line, I would cover your base and answer it exactly how they ask it. How am I going to answer it? 309 fewer people. So I'd write therefore, and again, I know I'm squeezing it in, but if I scroll, I lose the whole problem. So 309 fewer people. Done. All right, last up. This is a very common question. Put a star by it. Calc 2 just had to take a 2-question Frappy test on this, and both of theirs had a question where it said what was the maximum amount of water in the pipe, and this one said find the minimum wait time. So it was they always ask a max or a minimum. So let's go take a look. In this class, how have I told you to find candidates for absolute extrema? What do you always consider? Endpoints. Do that if you know nothing else, because you'll get a point where it says student considers endpoints. So I know that this was at a maximum at time t equals 0 or time t equals 30. Maximum number of people is what I'm looking for, right? It can also occur anywhere where what happens? Where else can there be a max or a min? At an endpoint, or let's put that on there. Like any function can have a max or a min at an endpoint or at a what? Critical value, correct? Now we can be a little bit more specific with this one, because here's the deal. It's for people in line. And the area under the curve represents people in line. So I actually have 2 critical values, one here and one right here. But I can discard one of them. Who don't I need to consider? The dot on the left or the dot on the right for a maximum? The right doesn't need to be considered. We just said they lost 309 people by then. How could that be a maximum, right? So I really need to, if you put both on a table, you'll be fine. But I really need to only consider that left-hand one. This is where you have to be careful, because I don't plug it into W. Cancel that off. I have to figure out how many people there were at that time. Well, at time 0, they told me, right? How do I figure out how many people there were at time 30? Tell me what I do on my calculator. I will take the 400 that were in line. Thank you. Add it. Yeah, to the amount that accumulated, the integral from 0 to 30 of w of t dt. I'm not going to put what that is at this. I really don't care right now what that is, and I don't want you to waste time on your calculator. However, for this one, it would be 400 plus the integral from 0 to 4.924 w of, was it w of t? Yeah, w of t dt. Now some common sense. We'll get numbers for those. But common sense, do you think the max was at the beginning? Yes or no? Totally not, because I gained positive area, which means positive people, just from there to there, right? So I know that's not the max. These are really my viable candidates. Then I lost a whole bunch, 309 to be exact, right? And then I gained a pretty big chunk of people, bigger than that over here, right? So do you think the max is at the end? Or at the 4.924. It's actually not. It's at the end, because you see it's going to gain all these people in that last chunk of time. If you did it on your calculator, I want to say this one ended up being like 5:30, and this one ended up, am I right? 4:30, thank you. And what did this one end up being? Did someone do that for me? Thank you guys, 565. So this one's the maximum number of people. So common sense actually is super helpful in these. Next up, the last one I'm going to do with you. This was the actual one. That was a fake one from an AP prep book. This one's an actual one from 2013. All right? And this was the first year I taught calculus, and I remember them coming to my room after the test, and I said, how did they go? And they said, we had one FRQ we didn't have a clue about. And I said, what was it about? And they said, something about gravel. And I was like, well, what about? And they couldn't remember, so it didn't really matter. But it was this one. And when I pressed them about it later in the week, once they published the questions, I said, what goofed you up about it? They said, we didn't know what unprocessed gravel was. I'm like, oh, that doesn't matter. It's right in, right out. It doesn't matter what's going in. Consider that your chicken nuggets. I mean, it doesn't matter what it is, that you don't know what it is. It's just that stuff's going in, stuff's going out. So for part A, let's go take a look. We've got a work day. Rate in tons per hour at which gravel arrives at a plant. So I would draw yourself a really crappy truck with some gravel in it. I really would. I mean, it seems silly and you won't get any points for it, but draw yourself a little truck. It says it's arriving at a plant and it's dropping gravel off at a rate of G of T tons per hour. All right, so I would write G of T, and I'd even put tons per hour. That is your rate in. So here's the situation. Trucks full of gravel arriving at the gravel plant, dropping off gravel at this rate. It already has 500 tons of unprocessed gravel sitting there from the previous workday. So it's dumping it in. There's already some there. Then it says, during the time that the plant's open for 8 hours, this was a less than or equal to 8, sorry, it's right there too, but it says that the plant is processing gravel at a constant rate. Well, that's because machines process it, and machines work at a constant rate. So I'd have a rate out at 100 tons per hour. So get your brain around the situation, and it becomes way easier. Unlike those f of x, g of x, concavity, inflection, where it's weird, these aren't weird. They're very straightforward. Gravel's coming in, there's stuff there, they're processing it and shipping it out. Do you get what's going on, Dylan? All right. I would highly suggest putting this in Y1. Whether you need to graph it or not, it always makes things quicker in the long run for an FRQ. For multiple choice, it doesn't. I'd put that in Y1. I wouldn't hit graph. I would just let it sit and see how we need it. And make sure, you're in radian mode. All right, here we go. First question says, did I give you enough time to enter that in Y1? I actually want it in there. We're going to bring it in using our vars. It says find G prime of 5. I'm going to draw an arrow to what I need to find. How do I go from G to G prime? Take a derivative. How do I do that when I have a calculator? Math 8. Exactly. Don't write Math 8 in your work. That's not acceptable. But you could do this. The derivative with respect to time of G of T. It won't even require you to show this, but it's good to show that you know what you're doing. Or you could write derivative with respect to x of g of x at x equals 5. Either way, but then make your calculator do it. And if you already have it entered, bring this in using your vars. So go do that. Do math 8 derivative with respect to x, vars, y vars, and bring it in. The more you use your calculator, the better you're going to get at it. And it'll tell you what the derivative of that rate is. And I think it's negative 20 something. That's all I can remember from. Yes, and we round to 3 decimal places. Now, that'll give you one of the 3 points for this question because it says using correct units, which means you get a point for the right label. They don't say that, they don't give you a point. But this one, they're telling you use correct units. What is my label? I just took a derivative of something that was already tons per hour. What's my label? Tons per hour per hour. Yeah, and you can write tons per hour squared or tons slash hour. But every time you take a derivative, you add the word per. Every time you integrate, you erase a word per. That makes sense, right? So next step, it also says interpret your answer. What word is this? That little symbol is the word what? Per, derivative, or rate. And when you're describing it, what word do you think I'm going to choose? The rate. Exactly. The rate of. The rate of what? The rate of, you could put G of T, or you could put unprocessed gravel arriving at the plant, or you could put the rate of, and last hour they said the rate of gravel arriving at the plant. That's true, right? Because G of T is the rate that it's arriving at the plant, so I accepted that. They said the rate arriving at the plant. And then what do you think we should write? Is what? Give me a word, a good word. You could say is negative 24.588, or you could say this is the rate of the rate. I forgot to put gravel, but whatever. You could say decreasing. Be careful with this though, because if you say decreasing, you've got to remove your negative, right? Because the decreasing will absorb it. So say is decreasing at 24.588 tons per hour squared. I'm just going to go like that. Boom. That's question 1. Derivative, Math 8 on your calculator. All right, Bruno, got a question for you. So chicken nuggets, right? Do you eat them? Me either. They're disgusting. I don't eat chicken nuggets. I don't eat chicken fingers. I don't eat chicken smiles. I don't eat any of that. It's gross. But you guys eat them. You eat them a lot. And we're going to use that scenario. Part B, the same question with chicken nuggets. I want to know if the amount of nuggets in the bin is increasing or decreasing at 12:30. What do I compare? So there's chicken nuggets in a bin, and I just want to know, did that increase or decrease at 12:30?
What is at 12:30 compared to what it started at?
No, not necessarily. So I've got the nuggets sitting there, and I've got stuff going in and stuff going out. And I just want to know if what's sitting there at any given time is increasing in amount or decreasing. What two things would I compare? The compare what? G of T, yeah, the rate in, find it, to the 100, the rate out. Yeah, all you're doing is comparing rate in and rate out at that time. Because if rate in is greater, it's increasing, right? If rate out is greater, it's decreasing. So thank you. I liked how you said G of 5. Let's do that. We need to find this is actually rate in. Now, it's already in Y1, so use your table. Just go hit second table and have it hit 5, and it'll tell you what that value is at 5. It's 90 something, 98.1, whatever. You guys can finish it off. That's my rate. And again, this is tons per hour at hour 5. That'd be about 2 p.m. on a workday. That's the rate that the trucks are bringing it in the 5th hour of the workday. What rate is it going out on the 5th hour of the workday? The 100, yeah, at any time. Those machines are cranking it out at 2 o'clock, at 1 o'clock, it's always leaving at 100. My rate in is less than my rate out. So is the amount of unprocessed gravel, aka this pile right here, increasing or decreasing at hour number 5? Decreasing. So you have to answer that. You have to say, therefore, decreasing. Or you could say unprocessed gravel is decreasing, but I'm getting lazy because I've done this all day. All right. Next. That was actually part C, right? Nope. Oh, we forgot part. Did we do part B? I forgot part B. Let's put a C there. My bad, I forgot part B. Part B says find the total amount of unprocessed gravel that arrives at the plant. That has nothing to do with this, how much is there. Nothing to do with this, the rate it's going out. It's all about how much got dropped off during the 8-hour workday. How do I go from tons per hour to tons of gravel? Integrate. What am I going to integrate? Yes, thank you. I'm going to integrate from 0 to 8. What function? Just G. Yeah, that's all I want to know. The amount that arrived there. And again, bring it in under your vars, bring it in under your Y vars. And I do want a good answer for this because I need it later, I remember. It'll help us go faster if I get the right, accurate. It was 800 something. 800, 800.5? Oh, 25 point what? 551. What's my label on that then, Joel? Tons. Yeah, tons per hour times hours gives me tons of gravel dropped off at the plant. Now back to not losing track of what's going on here. This much got delivered in 8 hours. This much was already there. How much left in the 8 hours? How much left the plant? 800. Exactly. So did the pile grow or shrink? They didn't ask that, but you should know. Did the pile grow or shrink at the end of the day? It grew. Exactly. This much got delivered, 800 got taken out. Doesn't really even matter how much was there if they asked that, but they didn't. Part D is the one that they always ask. What is the maximum amount of unprocessed gravel at the plant? Are they talking about the truck coming in, the pile, or the amount going out? Maximum amount of unprocessed gravel at the plant at any given time. The pile. Okay? So you really need to figure out when that pile is going to be the highest. Let's go put our candidates on here. I have 2 for sure. Who are they? 0. Maybe it was the most it ever could be. If rate out was always greater than rate in, right? Or at the end of this scenario, which would be at 8 hours, could I figure that out? I totally could. Let's put A of T for the amount of gravel in there. Or you could put P of T for the pile. Don't put G though, because G's the rate in. I want to know the amount that's there. This is 500 tons. Let's figure out at the end of the workday how much was there. The 500 I started with, right? Plus what? The 825 that we just said got dropped off, minus 800. Okay? Did it? Sorry, if you're listening to this recording, there's an announcement. That's why I stopped talking. They're priced. They're going to when you watch it. All right, so back up to this. This for sure then is not my maximum. Who is my other candidate? Well, if you can't find it, you just quit right here. But you also have to figure out any place where what would have happened. Technically, we call them critical values. Well, I'm going to do it with calculus and I'm going to cross it out and show you common sense, but just one time only. This is what College Board will show but not give points for, and I'm going to tell you combat it with common sense. The amount at any time is going to be the 500 that was sitting in the pile plus the amount that got delivered. So we would say from 0 to T, I don't know, minus the 100 an hour that gets taken out. Are you okay with that? Again, this is the calculus of it. 500 was there. This is what got dropped off. This is what got processed. I need to figure out anywhere where the derivative of that equals 0. Here's my derivative. A prime of t, constants go to 0. The derivative of the integral undoes it, right? It just causes a dump, right? Minus, what's the derivative of that? 100. Again, I wouldn't write this. I'm going to show you a shortcut way that's way more common sense. In order for this to equal 0, the rate in, g of t, would have to equal the rate out. Wouldn't you agree? Now let's talk about it in terms of babies, people. Rate in would be births. What, right? What would rate out be? Deaths. If there's always more births than births, that's hard to say, births than deaths, right? When's the maximum population going to be? Always more births than deaths. When's it going to be? At the end of my time interval, right? If there's always more deaths than births, rate out's always under rate in, right? Then my max was at the beginning. It's the endpoints when the two shall never cross. If something's always increasing, it's endpoints at the end. It's maxes, right? So if you want to figure out where there's a change up, right? If there's always more nuggets going into the bin, always, then you're taking out, then the max is at the end of the lunch period, right? So for you to figure out the critical values, you just need to figure out where rate in equals rate out. That's the quick way to do it. They have to cross. Otherwise, it's an endpoint. Raise your hand if that makes sense. The two must cross. Rate in must cross with rate out. They must be equal. Otherwise, one is always above the other, and the minimum, maximum values are at the endpoints. So on your calculator, how do you figure this out? Do you think you graph this in y1 and this in y2 and calc intersect? The answer is you could. You really could. It's easier, though, to graph that one. So I would just go to your calculator. You already have g of t in there. And do what with it? Just put a minus 100 on it. And you're going to go graph it. And you're looking for the zeros. And it'll give you your candidates. And you're just looking for it to cross the x-axis between that 8-hour. How many times does it cross? Once. Okay? You're going to calculate that. And it goes right here. That is the one possible time where it either reached a minimum or a maximum. I don't know what it is. I'll wait for a calc 0. What time was it? 4.92 what? 3. Now how do I figure out how much was there? I go like this. I had the 500, right? Then stuff got delivered, right? And then how do I write how much left? Minus what? 100 times that. Yeah, which would be 492.3. I have no idea what that is, but I think it's bigger. I think last hour they said it was 5. It's 635. I have dyslexia. I was going to say 560. All right. Anyway, 635 tons. So is the question, now I lost it. Was it a maximum or a minimum? Max. So the max amount on this one was at the interior candidate. For the last one we did, it was at an endpoint. Do you see why you have to check both? All right, now for the assignment. All right, I will not see you tomorrow, and I do have to give you something to do. It's not very labor intensive. On the front of your packet, the very front page, I want you to write this. Test Monday. What will the date be? Somebody figure that out for me. Monday the 24th. You're going to have a Frappy test. You should now kind of know what it's going to look like. You should know how to prepare. Those of you who prepared last time, 37% of you got over 100 on it. Right? Those of you who didn't prepare, 13 out of my 86 who took it, failed it miserably. Why? They didn't look at them. Okay? They don't go well if you don't look at them. You get national averages. So there'll be 2 from the packet, and there'll be 1 what? That wild card will go very, very well and cause you to go over the average if you prepare for the other 2. It always does. I've been doing this for years, and it happened with you guys, like almost statistically exactly the same as always happens. Then for Thursday, you need to do 3 of them, and I'm going to check that they're done. I'm going to make them 5 points each. That's a pretty hefty assignment for not much time put in, but I want to make sure you do them. You are going to do these 3. Stormville. So if you want to go in your packet and put a star by it, there's one that says Stormville, it's raining. There's a rate in into a bucket. You're going to do Janet's driveway. It's snowing. She gets up, starts to shovel. So there's a rate in, rate out. And then there's one with a rock concert. It's the very last one. Those 3 are the 3 I'm going to check on Thursday. What you're going to do if you struggle with this content and aren't sure, you're going to do them while watching the video solutions. Where do you think I have those? They're in Schoology. Yep. So you can either, if you're like, I still don't get it, you can just do them with me. I spend like 7 to 10 minutes on each. So it's probably an average about 25 minutes to do those 3 with me. If you want to try them on your own and then watch the video, you could do that as well. But I will check these. When will I check them? Thursday when you come in. I'll just collect your packet while you do something else, and I'll just check off that you did them. Again, do them authentically. If all you do is like copy it down to get it done, at this point the homework points don't mean anything anyway. Like Joel just said, he had to take a goose egg on one. In the grand scheme of the hundreds of points that are in my grade book, it doesn't matter. So don't worry about getting it done. Worry about getting it done right. What do you think? Can you do it? This one? We
Well,
can.
not
We can.